Today's lesson's on simplifying radicals. Let's look at this first example. First thing let's break it into several pieces here. Square root of 32. First thing I'm going to do is take that. I realize that it's a decimal, so I'm going to treat 32. After I treat it, I'm going to get my prime factorization. I have 5 2's. And since it's square root, I want groups of 2. I have 2 groups of 2, so I'm going to multiply 2 times 2, which is 4. That 4 goes outside, and they keep the 2 inside. Now I have 5 x's. I want groups of 2. I have 2 groups of 2, so I have x squared outside the radical, and I have 1 x that remains inside. Y to the 4th. I have 4 y's. I want groups of 2. I have 2 groups of 2, so I have y squared and no y's left. Remember to check this using your calculator. First thing I'm going to do in the second example is take the square root of 40. I realize that it is a decimal, so I'm going to treat 40. I have 2, 2, 2, 5. I want groups of 2. I have 1 group of 2. Goes outside the square root. I have a 2 and a 5 left, so I'll multiply 2 times 5, which is 10. I have 3 x's. I want a group of 2. I have 1 group of 2. And I have 1 remaining. Y to the 7th. Groups of 2. I have 3, so y cubed goes outside the radical, and the 1 remaining y is left inside. Let's look at these two. I have cube root here. First thing I'm going to do is take the cube root of 8. I realize that that's 2. Saves me from having to tree it. This time I want groups of 3, since my index is 3. I have 5 x's. Groups of 3, I have 1 group, and I have 2 remaining, and x times x is x squared. Y to the 9th. Groups of 3, I have 3 groups of 3, so that's y cubed. It goes outside, and I have none remaining. Remember to check using your calculator. Cube root of 96. Take that, it's a decimal. So I'm going to treat. I have 5 2's and a 3. Groups of 3. So I have 1 group of 3. Goes outside. I have a 2, a 2, and a 3. So 2 times 2 is 4, times 3 is 12. I have 5 x's this time. Groups of 3. 1 group of 3. 2 remaining. X times x is x squared. Y to the 7th. Groups of 3. I have 2 groups of 3. Sorry for the interruption. We have y. 2 groups of y, and 1 remaining. Remember to check. Let's look at these. Next one I have is the 5th root. So we're going to do the 5th root of 243 first. And that would be 3. So it's going to go outside. That way I don't have to tree it. Notice that the indexes are staying the same. I have 10 x's. How many groups of 5 can I get? That would be 2 groups of 5 with none left over. I have 8 y's. How many groups of 5 can I make? 1 group. And there's 3 left over, so 3 inside. Now let's look at the next one. 4th root of 160. I take the 4th root of 160. I get a decimal. So I'm going to treat it. get 5 2s and a 5. I want groups of 4 because my index is 4. I have one group that goes outside. Notice my index stays the same again. 2 times 5 is 10. This time I have 7 X's. How many groups of 4 can I make? One group. How many left over? 3. Y's. 5 Y's. How many groups of 4? One group with 1 left over. Remember to check using your calculator. Now, this one looks a little different. But remember, x minus 3 to the 4th power, all that is x minus 3 4 times. If I write it 4 times, now I want to make groups of 2, because I have square root. How many groups of 2 did I make? 2 groups. So what was my base here? X minus 3. And I made 2 groups, so square. Now, let's expand this. X minus 3 squared means x minus 3 twice. And now I'm going to distribute. So I get x squared minus 3x plus 9. Combine like terms, x squared minus 6x plus 9. Remember to check. All right, let's look at my next one. I have 2x minus 5 4 times. I want groups of 3 this time because my index is 3. I have one group, so that goes outside. And I have one that remains underneath the radical. There's my answer. Check it using your calculator. Here's a couple problems for you to try.